we're going to focus on flow control. And since the macro inputs and outputs are in the flow control, we'll touch on those a little bit. If we have time today as well. So, when we talk about flow control, it really is just a matter of controlling the flow of the logic. With the way that the nodes work, basically making like a train, right? Each line is a track on the train. The logic flows from line to line to line, triggers whatever event is in that node, and then moves on to the next lines, carrying out whatever it is that those nodes are doing. And the flow control is just kind of like the steering that logic. We have things like our branch node takes in any Boolean value and gives you an event for whether it's true or false. So we talked about the Boolean values and the variables, right? Basic Boolean, pass the Boolean into a branch node. And then if the Boolean is true, I can go do one thing, and if it's false, I can go do another thing. This usually comes in handy with things like, I know we haven't gotten to them yet, but like an equal node, you're trying to check if two actors, I guess two anything, I just grabbed the actor one, but two actors are equal, you get a Boolean out of that, which you can then run through a branch. If they are equal, you can do some logic. If they are not equal, you can do a different set of logic. So it really just creates that branch of one way or the other based on the value of your Boolean. Your and your ors, we'll talk about those a little bit at some point in the future, but that will let you do, you have two different things that need to be true. You can do an and, or if you have one or the other needs to be true, you can do an or. And that Boolean can go into the branch as well. Alright, so anything that outputs a Boolean can be fed into a branch node. And whether that Boolean is true or false, you have an event for that. So you can trigger logic off true or false. So that's pretty straightforward. The branch node, the counter node gives you a quick way to trigger something after something happens a certain number of times. So for instance, if you want some action to happen after the player has entered a room 3 times, you have your starting value, your comparator number, and then equal, more than, or less than. Should probably be greater than, less than, but more than, less than. What that does is, depending on the behavior, if it's equal, more than, or less than, your event will trigger when your counter is either equal the comparator, more than the comparator, or less than the comparator, based on the behavior you have there. And then you have increment by 1 and decrement by 1 and reset. So you could have some logic flow that increments that by 1, and this connects to some other logic flow. If this isn't equal to 3, it's not going to fire anything. But the third time this goes through and increments by 1, it then will be equal to 3. My event will be true. It will perform some action. If I want that to happen repetitively, then I would just reset this every time it's activated. If I want it to happen every time after that happens, I could just do it more than. So if the number is more than 3, every time it's triggered after it reaches 3, that event will be triggered as well. So just a simple counter gives you the ability to trigger some event after the counter has reached a value. Flip-flop node The flip-flop node has an activate. It has on flip and on flop. And what this does is the first time you activate this, it will activate the on flip. The second time you activate it, it'll activate the on flop. And then it'll just cycle through them like that. So it'll do flip and then flop, and then flip and then flop. So if you want something like a quick way to do like a light switch, we talked about the on-off node. And so if I have one of these set to on, one of these set to off, on flip it's on flop it's off. Every time I trigger this, one time I'll turn it on, the next time I'll turn it off, next time I'll turn it on, the next time I'll turn it off. That's kind of a bit of a bad example because the on-off node has a flip option anyways, where every time you trigger it, it'll just flip it. So if it's on, it'll go off. If it's off, it'll go on. But you can do the same thing with the flip-flop node with other types of logic. If you just want to alternate between two different nodes based on whatever interaction's happening, that is your flip-flop node. Since we had the on-off node, it does exactly what it says. It'll turn something on, it'll turn something off, or it will flip it to whatever it's currently on, it'll flip it to off. If it's currently off, it'll flip it to on. So that one's pretty straightforward. Right, so if you have some kind of light, you can trigger the on-off on a light, toggled on and off with the on-off node as well. So things like a repeat node, which I guess we'll just pull up and talk about next. A repeat node, you can either have it repeat something a certain number of times. So if you want something to happen 3 times, you activate it, you set this to 3. It'll just activate whatever's connected to your on repeat 3 times, then stop. You can have it repeat infinitely, which means it'll just it'll repeat forever. And you can set a delay, and the delay is how long between each iteration of repeat. So whether it activates, waits a second, activates, waits a second, activates, waits a second. If you want something that will activate constantly, but be able to turn it on and off, that's where the on-off node comes in handy. Because if you turn a repeat node off, even if it's on repeat infinitely, it will turn it off. And if you turn it on, it'll start repeating again. So the repeat node, calculating speed. Let's see, a gate node. So a gate node gives you a way of blocking logic. What the gate node does is when I activate gate node, the gate has 2 states. It's either open or it's closed. If the gate is open, then my onActivate event will trigger. The gate is closed, then my onActivate will not trigger. So I can have some logic that is dependent on something else happening, which means I can have my gate be closed, and that was open, closed, and some other logic that opens it. Then you have a toggle, so you can just toggle it between them if you wanted to just toggle. I personally am not a huge fan of these toggles because I like to know the state that things are in and not just assume. But if you have something where it doesn't really matter, you can just trigger the toggle on whether it opens or closes the gate. And all that does is, again, if we go with the analogy of your lines are a train track, if the gate is closed, the train can't go through. If the gate is open, the train can go through. I'll throw this back over here. And then lastly, we have a sequence node. And a sequence node, I guess not lastly, we have the random node too. A sequence node lets you order logic. So you'll find yourself a lot of times in scenarios where you have multiple things that need to happen as part of a logical flow, but you need them to happen in a certain order. And that's where the sequence node comes in. You have event 1 and event 2. When you activate the sequence node, it'll activate event 1, and then it will activate event 2. I haven't done a whole lot of testing to know if event 1 waits for whatever chain of logic here is to be finished before it activates event 2, or if it's simply it activates it, waits a tick, and then activates the other one. But it does help you keep things in sequence. And then a good thing to know about the sequence nodes is you can chain them together. So event 1, event 2 activates another sequence node, which then activates event 1 of something else. Event 2 activates another sequence node, and you can chain them together if you have more than 2 things that need to be in sequence. And then lastly, out of these nodes that we have here, we have the random node. The random node, you can connect your random trigger to any number of other nodes. When you activate random, it will randomly activate one of these, but not all of them. So if you're trying to create some randomness in the way something behaves, you can hook this up to multiple different interactions with the world and let that run so it randomly does things. One of the things I use this for is like ambient sounds. There's, a handful of different cricket noises or things like that. Hook them all up to a random trigger and then put a timer on that. So every so many seconds it triggers a cricket noise, but then it's a random pattern of those cricket noises, so it sounds more realistic to the player in the game. So just one useful example of how to use the random nodes. That was our crash course into our flow control nodes. We do have a little bit of time, so we are going to take a look at the macro nodes. These are some of my favorite nodes over here. So to demonstrate how the macro nodes work, we're going to go ahead and convert this into a macro. We have our macro input node and our macro output node. And if you're familiar with programming concepts at all, you can think of this as how you would build a function. A function takes in input parameters and outputs a value. So your macro input is your input parameters. Your macro output is your outputted value. So if we want something like the vector that we are trying to print out, and the string that it turns into, right? We input the vector, we output a string, and because we generally don't want these things to just happen automatically, I can input a macro for triggering the logic, and I can output a macro for when the string is done being calculated. With these macros, you can give them a name. So we're going to call this stringify vector. I'm going to call this one vector. And you can give them a description. You can change the icon that it uses. Here we're going to put just the play button. The vector, we're going to do variable input. The output, we're going to do variable output. We're going to call this vector string. And this one we're going to do on finished and on vector stringify. And you also have a stack order, so you can control the order in which these nodules appear. What that means is, if I now take all of this and make it a group, call this stringify, collapse my logic, I now have stringify vector, vector on vector stringified, and vector string. Which means I can take this, let's just do on player spawn, get your location on player spawn, we'll get that player's location, which is a vector. We'll feed that vector into our stringify vector, and then we'll get our log here to output that to a log. If we go ahead and hit play, you can see we have the log over there, or where the player spawned in at. So this, with the macros, in my opinion, is very powerful, and that it allows you to essentially create your own nodes. So you can have some kind of repeatable logic flow that you want to use. You can hook it up with a macro, collapse the logic, and now you can repeat it. So if we do a similar thing, right? So if instead of getting the player's location, get actor transform. We talked about transforms and how a transform is a collection of a location vector and a rotation vector. If we want a way to print out that data of the transform, right, we can get the transform value, we can break the transform value, we can feed the location into here, we can feed the rotation into here, and then the scale is just a number, it's not a vector. If we grab a couple logs here, we're actually going to do something like grab a string, or concatenate string. We want to do location, rotation here, we want scale. We load into that, you'll see we get location with our vector, rotation with our vector, and scale with just the number. And so we used our macro that we made, just plugged it in twice here, so we can call up our two different vectors, the location and the rotation. used our string concatenation that we talked about before to combine with values for labeling. And then if we want to take this even a step farther, we can make this a group and do the same thing we just did with the stringify vector. Something like this. Transform, variable input, stringify, transform, and then over here, instead of having the logs here, we didn't add these to the group, so let's get all these guys added to the group. So we can go ahead, that guy there, that guy there, that guy there, that guy there. This will get me our location string. I'll actually get rid of this concatenate, so we probably don't want that inside macro. Then we'll take this guy, so that's the end of our logic flow. We have our location string, rotation string, scale string, and on transform stringify. So we'll just order these. These three make variable outputs. This one we'll do unfinished. Collapse that logic. Sort of that better. All this stringify transform. Now I can just feed a transform into that and have location, rotation, scale. Activate all of those. Now they're not labeled, so which one's location, rotation, scale yet, but we have our vector coming out for each of those three. And if we wanted to label those, we will do that out here. Just get rid of those. Do our location, rotation. Then we just feed each one of these into a log. Clean up a little bit here, and if we play that, we should have our labels back to location, rotation, and scale, which we do in the logs right there. So you can see how this is much cleaner than this. Takes up less space, and it gives you those reusable chunks of logic, so you don't have to keep rebuilding them. You don't have to keep copying and pasting. And then if you really want to, you can just create stamps out of these and then just reuse them anywhere. You can just grab them out of your stamp library. I already have a stringify vector stamp, but we're going to create another one anyways, because I kind of like how I did this one better anyways. converts a vector to a string. Then we'll even just go ahead and publish these 2 stamps. Which means you guys out there can just go and grab these stamps and use them if that's something that you need. Hopefully that information was helpful.
If you enjoy this content, don't forget to like, comment, and subscribe. See you in the next one.